Welcome to Unacademy, the largest online e-learning platform. We were dealing with circuit theory crash course. Today we'll be discussing lecture 7 resonance. Before that, let me tell you I'm Y Shravan Kumar, having 7 plus years of teaching experience and mentored more than 5k students and cracked GATE. And also let me tell you the Unacademy app installation procedure. Type Unacademy learning app and you'll get Unacademy learning app installation. Click on this. Then if you're opting for GATE and engineering services, you can click on this. Then you can click on plus subscription and click on this get subscription as step 5. You'll have plus and iconic subscriptions. You'll get a dedicated mentor for your preparation. You'll get a dedicated mentor for your preparation. For iconic subscription, you can use my code as YSK10 to get the maximum discount and click on this proceed to pay. Once you click on this, you'll have payment options, debit card, EMI, UPI, wallets, net banking. You can use any of these platforms to get subscription to the Unacademy. Now let me tell you about the Unacademy Combat, India's largest fortnightly competition for GATE. The best questions by the best Unacademy educators as a combat. So there are challenging questions by our best educators, Unacademy educators. Questions guaranteed to keep the test engaging, challenge, and fun. That is super fast and fun with real time rankings. See how you rank against the others with a live leaderboard after each question, each and every question. So the competition with the best, know where you stand among the all other contestants. And you'll have a detailed video solutions by the top educators. Get in-depth video solutions for the questions right at the contest. And compete, crack, and conquer. You'll have a score, leaderboard, and rating and awards even. Compete with the best and win amazing prizes like Apple Mac Air, Apple iPad Mini, Apple AirPods, Amazon vouchers of rupees 1000 for the top 100 rankers as well. So I want you guys to share this link, and there is a delay in our sessions today due to some problem, and I want you guys to share it with maximum students. बोलो कि सबको join करे. Then the Unacademy Combat, as I have told you, you can win exciting prizes. And this is India's largest fortnightly competition for GATE, challenging GATE questions, super fast and fun with the real-time ranking, and compare with the best detailed solutions. Enroll for free. It's December 16th, 6 p.m. You can register now. So coming to today's topic is resonance. Today's topic is resonance. We will be discussing as a part of circuit theory resonance concept will be discussed today. So first let me consider a series RLC circuit. So we are discussing resonance. So resonance, we will be discussing a resistor, inductor and a capacitor that is in series with a sinusoidal signal is given. To this are resistor, inductor and capacitor. Now to this there will be a flow of current and there is a voltage. Let this input voltage be V is equal to Vm sine omega t. V is equal to Vm sine omega t is the input voltage. Now when do we say that a circuit is under resonance? When do you say that the circuit is under resonance? When do you say that the circuit is under resonance? When the voltage and current are in phase. V and applied voltage and current are in phase. when the applied voltage and current are in phase, you can say that the circuit is under resonance. Or if the power factor is unity, if the power factor is unity, then you can say that the circuit is under resonance. The circuit is under resonance. So a circuit is said to be a circuit is said to be under resonance if its power factor is unity, or voltage and current are in phase. Voltage and current are in phase. So these are the two important points that you need to remember for any circuit. That is, the phase angle here is 0 degrees. It is 0 degrees between, the phase angle is 0 degrees. The phase angle is 0 degrees. A circuit is said to be under resonance. A circuit is said to be under resonance if the power factor is unity and if voltage and current are in phase. If the power factor is unity and if the voltage and currents are in phase, then the circuit is said to be under resonance. Hope this point is clear for you. Now let us consider there are two types of circuits. One is series resonant circuit. And the other one is parallel resonant circuit. The other one is parallel resonant circuit. So let us first consider a series resonant circuit. Let us consider a series resonant circuit. So I want you guys to share it to maximum students so that they will know about this session on resonance. So let us consider what is series resonance. Let us consider what is series resonance. So a series resonance circuit, let us consider there is a resistor and an inductor and a capacitor which is excited by some AC source. So this is R, L and C. So this is a series resonant circuit. A circuit is said to be under resonance if the power factor is unity and if the power factor of the circuit is under resonance, and also voltage and currents, if the power factor is 0, then the voltage and currents are in phase. Now if you consider this is a series resonant circuit. This is a voltage, so V is equal to Vm sin omega t. Vm sin omega t. This is the input. Now this circuit, for this you can write this as JXL and this as minus JXC. So what is the impedance of the circuit is R plus J into XL minus XC. R plus J into XL minus XC. Whenever voltage and current are in phase, you can also write this impedance first as magnitude and angle. Magnitude at an angle phi. What is the magnitude? Magnitude of impedance is equal to under root of R square plus XL minus XC whole square. What is the phase angle? Phi is equal to tan inverse of XL minus XC by R. Because if you have X plus R plus JX, let us say you have something like R plus JX or A plus IB. What is the magnitude? Let us say F. This has F. What is magnitude of F? It is under root of A square plus B square. Similarly, what is the phase angle? Tan inverse of B by A, imaginary by real. That is what I have written here, imaginary by real. Now let us write. Now let us try to write. Now let us try to write. Let us try to write this as, so Z is equal to, we have written what is Z is equal to R plus J into XL minus XC. So you can write this as, at under resonance, what can you write? Imaginary part is equal to 0. Imaginary part is equal to 0 under resonance. Imaginary part is equal to 0. What is the imaginary part? Good evening, Nikhil Chakravarti. Good evening, Soumya. Good evening, Shivakumar. Good evening, Karthik. Good evening, Ravi Kumar. What is imaginary part? XL minus XC is equal to 0. But we know already what is XL. It is omega L. What is XC? It is 1 by omega C. So under resonance, imaginary part of Z is equal to 0. Imaginary part of Z is equal to, imaginary of Z equal to 0. XL minus XC. What is XL? Omega L. Minus XC 1 by omega C is equal to 0. So can I write this as, we'll call this as omega R and this also as omega R. So we can write omega R into L is equal to 1 by omega R into C. Omega R into C. Now can I write omega R square is equal to 1 by LC? What is omega R is equal to 1 by root LC? But we know what is omega as 2 pi F. So 2 pi F, it is omega R, this is FR. If that is omega R, this is FR is equal to 1 by root LC. So what is FR is equal to 1 by 2 pi root LC. So this is called as resonant frequency. This is called as resonant frequency. FR is equal to 1 by, Rishikesh, good evening. Anup Sagar, good evening, Anup Sagar. So under resonance, imaginary part of Z is equal to 0 or XL minus XC is equal to 0. When XL minus XC is equal to 0, when XL minus XC is equal to 0, it is under resonance. We already know XL value as omega L and XC as 1 by omega C. So omega is equal to 2 pi F. Substitute this here in this equation. You will get XL value and XC value if you substitute it and make it equal to 0. You can write omega R square is equal to 1 by LC. Omega R is equal to 1 by root LC. Omega is 2 pi F. So if this is omega R, this is 2 pi R, 2 pi FR. So when you write this, you'll get FR is equal to 1 by 2 pi root LC, which is the resonant frequency. What is resonant frequency? It is the frequency at which the circuit is said to be under resonance, or the frequency at which the power factor of the circuit is unity or the frequency at which the voltage and currents are in phase. The voltage and currents are in phase. So this is the resonant frequency. Now let us try to write. Let us try to write impedance Z is equal to R plus J into XL minus XC. Now if you look at this, when omega is equal to 0, what is the value of impedance? When omega is equal to omega R, what is the impedance? When omega is equal to infinity, what is the impedance? Even you can take the magnitude or you can also take the total impedance. You can also write this as R plus J into omega L minus 1 by omega C. We are trying to draw the impedance graph, impedance versus frequency graph. Now when you write this omega is equal to 0, what is the impedance? Z is equal to, when omega is equal to 0. See, let us substitute omega is equal to 0 here. If you substitute omega is equal to 0, this is 0. And if you substitute this is 0, 1 by 0 is infinity. So impedance can be taken as infinite. Now when omega is equal to omega R, this is 0. You'll only get Z is equal to R. So this is Z is equal to R. When omega is equal to infinity, when this is infinity, this is 0 and this is infinity, then you can say that it is approximately. These are all just approximations to make you understand. Now let us consider what is the current. First I'll try to draw the impedance diagram, impedance graph. So this is impedance versus frequency. Let us consider impedance on y-axis, impedance on y-axis, and frequency on x-axis. Let this be omega r, let that be omega r. Now when this omega is 0, approximately its value is somewhere here, so we'll get a graph something like this. So this is impedance versus Z versus omega graph. Similarly, in the next case, if you can take the current, if you can take the current, we know Z is equal to impedance, Z is equal to R plus J into XL minus XC. Now what is at omega is equal to 0, what was the impedance? It was infinity. And omega is equal to omega R, impedance was R. At omega is equal to infinity, impedance is again infinity. What is current? I is equal to V by Z, right? If impedance is infinity, current is approximately 0. If impedance is R, current is equal to V by R. If impedance is infinity, I is equal to, this is I naught we call it as. If impedance is infinity, this is again 0. So can I draw a current versus frequency graph like this? This is just to make you understand how it varies. So can I draw, if this is current and versus frequency, if this is frequency, so at omega is equal to 0, it is approximately 0 and this will increase to R and then again it will decrease. So this point, so this is omega R, resonant frequency. So this is we have seen what is impedance versus frequency graph, and we have also seen what is impedance versus current. Impedance versus current and impedance versus frequency and current versus frequency. It is impedance versus frequency and current versus frequency. These are the two graphs that we have drawn. All right. Hope this is clear for you. We have taken what is a resonance. A circuit is said to be under resonance if its power factor is unity, voltage and current are in phase. Then we have considered series and parallel resonance circuits. Then we have taken up this series resonance circuits as RLC. This is excited by some voltage. Z is equal to R plus J XL minus XC, and impedance at an angle. You can write the magnitude and phase angle of the impedance. And then I told you about what is under resonance. Impedance is equal to R, or the imaginary part is equal to 0, because the power factor is unity and voltage and current. In order to make them in phase, imaginary part must be 0, and we have made it and took what is XL and XC values and found what is resonant frequency. Then Prashant Reddy, good evening. Janardhan Reddy, good evening. Deepak Reddy, good evening. Janardhan Reddy, how are you? I'm fine. How are you, Janardhan Reddy? Thank you. So then we have taken impedance and approximate values we have taken for that, and also then I told you how it varies with respect to frequency, and we have seen that we have two graphs. One is the impedance versus frequency, and the other is current versus frequency graphs. So we have impedance versus frequency and current versus frequency graphs as well. So this is impedance versus frequency graph, and this is current versus frequency graph. Hope this you are clear with these points. Now let us see what is the relation between let us consider the impedance graph. Now this is impedance versus frequency graph. Sorry, this is impedance versus frequency graph. So this frequency is omega r, this is omega, this is impedance. Now if you look at these, at this point, at omega is equal to omega r, at omega is equal to omega r, that is under resonance, z is equal to r, impedance is equal to, what is the current then? It is v by r. Current is v by r. And you also have something called as half power frequencies. You also have something called as half power frequencies. Now let us consider the current graph. So let us consider current, which is varying like this, and this is omega r, this is omega, and this is current. This at this point, what is the value of current? I is equal to, that's what we have written, it is v by r. Current I is equal to v by r. Sumant Jilla, good evening. Lakshman, good evening. I naught is equal to v by r in this. Now we will discuss what is called as bandwidth. Now if you look at this, at this frequency, at resonant frequency, we have the current as the maximum value. Now at some point you will have the current as I is equal to I by root 2. So I is equal to, if you can erase this, I'll just write it down once again. At these points I is equal to I naught, it's not I naught, current I by root 2. I by root 2. Because now if you consider power, power is equal to, now if you consider power The power dissipated at resonant frequency is equal to I RMS square into R. So when this is RMS square, power is equal to Y. What is IRMS? It is I maximum by root 2. I maximum by root 2 whole square into R resistance. I maximum by root 2 whole square into resistance R. So this value, when the power is half of, when the, because we are speaking of half power frequencies, half power frequencies, at half power frequencies, power P is equal to, P dash is equal to maximum power by 2. Maximum power by, it is maximum power by 2. When power is half, then the current will be I is equal to I by root 2. When power is half, I is equal to I naught by root 2 times. So that is this frequencies over which the current is I by root 2 is called as the bandwidth. So bandwidth is equal to, this frequency is omega 2 and this frequency is omega 1. It is omega 2 minus omega 1 is the bandwidth. It is a range of frequencies over which the power is half of the maximum power, or the current is 1 by root 2 times, or 0.707 times. It is 0.707 times the maximum value. So that is called as bandwidth. So let us now try to find that value. Now what is that value? Let us discuss the half power frequencies. So let us consider the impedance. Z is equal to, first, Z is equal to R plus J into XL minus XC. What is current? I is equal to V by Z. What is V by mod Z? It is R plus R square plus, if you take, this is R square plus XL minus XC whole square. So that is at resonance, I is equal to I naught by root 2. So if you can simplify this, I naught by root 2, I naught by root 2 is equal to V by, this is under the root, V by under root R square plus XL minus XC whole square. XL minus XC whole square. But we know that I naught is equal to V by R under resonance. Under resonance. So you can, if you substitute, V by root 2 R is equal to V by root 2 R, if you write it, this is V by root 2 R. Root 2 R is equal to V by under root of R square plus XL minus XC whole square. Now let us try to take this to the next. We are trying to find the relation between half power frequencies and also what is the expression for the bandwidth, right? So now if you observe, we can cancel these two. I naught we have written it as, let me tell you, first we have considered impedance, then what is current? I is equal to V by Z. We have taken this mod Z. So I at resonance, I is equal to I naught by root 2. At half power frequencies, I is equal to I naught by root 2. So V by under root of R square plus XL minus XC whole square. At resonance, we take I naught is equal to V by R. So you write V by 2R, and then we have considered this expression. Now if you try to simplify this, you can cancel these two. You can cancel these two. You will get it as squaring on both sides. You will get 2R square is equal to R square plus XL minus XC whole square. 2R square is equal to XL minus XC whole square. Now if you take R to the other side, R square, because R square, 2R square minus R square is equal to XL minus XC whole square. You can further write this as XL minus XC whole square is equal to R square, or XL minus XC is equal to plus or minus R. XL minus XC is equal to XL minus XC is equal to plus or minus R. XL minus XC is equal to Sham. Hi sir. Hi Sham. Hi Sham. Welcome to circuit theory crash course. Welcome to circuit theory crash course. So XL minus XC is equal to plus or minus R. What is XL? We already know XL is equal to omega L. What is XC is equal to 1 by omega C. XL is equal to 1. XL is equal to omega L, and XC is equal to 1 by omega C. Now tell me, if you substitute XL is equal to omega L and XC is equal to 1 by omega C, what are the values of plus R and minus R? Consider two values, because you have two values of R, one as plus R and the other one as minus R. I want you to tell me the values of plus and minus R. So you can write XL minus XC is equal to plus or minus R. So what is XL? Omega L minus 1 by omega C is equal to plus or minus R. Now if you can still write this, I'll write this as omega 2L minus 1 by omega 2C. Omega 2C is equal to plus R. Omega 1L minus 1 by omega 1C is equal to minus R. These are the two values that I have taken. These are the two values. This is one value, because this is at two frequencies. We have taken these two values. So we will write omega 2L minus omega 2 1 by omega 2C is equal to R. Omega 1L minus 1 by omega 1C is equal to minus R. Now let us try to simplify this. First, add the above two equations. Add above two equations. Let us try to add the above two equations. What you will get is omega 2L minus 1 by omega 2C is equal to, plus omega 1L minus 1 by omega 1C. We are adding, is equal to R plus R, 0. So you can write this as, take common L, you can write omega 2 plus omega 1, if you take common. And if you take common 1 by C, it is, if you take common 1 by C, I'll take the minus also. Let's take this as minus. Minus, what is 1 by C of omega 2? This is 1 by omega 1 plus 1 by omega 2 is equal to 0. Now you can write this as omega 2 plus omega 1, omega 2 plus omega 1 into L is equal to 1 by C into 1 by omega 1 plus 1 by omega 2. Is this clear? Now let us try to take this to the next page and do the further classification. for this simplification. Now if you try to do furthermore, if you try to do, it is L into omega 2 plus omega 1 is equal to 1 by c into omega, sorry, we'll take the LCM directly, omega 1 plus omega 2 by omega 1 into omega 2. Let's just try to multiply this. This is omega 1 into omega 2. Now if you take this, you can cancel these two, right? So L into C is equal to 1 by omega 1 into omega 2, or you can write omega 1 into omega 2 is equal to, you can write omega 1 into omega 2 is equal to 1 by LC. What is omega 1? 2 pi f1 into, you can write omega 1 as 2 pi f1 into omega 2, 2 pi f2 is equal to 1 by LC. So if you write f1 into f2 is equal to 1 by 4 pi square LC, but we know that fr is equal to 1 by 2 pi root LC. So you can write fr square is equal to 1 by 4 pi square LC. So substitute this here. So f1 into f2 is equal to fr square. This is the relation between resonant frequency and half power frequencies. What is f1 half power frequency? What is f2 is also half power frequency. What is fr resonant frequency? What is fr resonant frequency? What is the relation between them? Fr square is equal to f1 into f2, or fr is equal to root f1 into f2. This is the relation between resonant frequency and half power frequencies. This is the relation between resonant frequency and half power frequencies. So this is the relation between resonant frequency and half power frequencies. Hope you are clear with this. What have I done? We have considered this power at half power frequencies. So here we have started, what we have started? Relation between FR, F1, F2. This is what we were actually to find. What was FR, F1, F2? This is I, this is current, this is omega. Here you have Fr or omega R. This part is the frequency at which current is root 2 times. This is the current I naught. So these are F1 and F2. These are frequencies F1 and F2. So we have considered this equation, impedance and current I is equal to V by Z, written what is the Z value, and taken I is I by root 2 at half power frequencies. So but I naught is already V by R, and the resonance current I naught is equal to V by R, because Z has only real part. So we have substituted that, and we have cancelled these two, and squaring on both sides you have got XL minus XC whole square is equal to R square. So from this we have written what is XL minus XC. We already know XL is omega L and XC is equal to 1 by omega C. And furthermore we have written omega 2L minus omega 2C is equal to plus R, and this has minus R. Then we have considered these two as plus R and minus R, and adding these two equations and just simplifying them, you got F1 F2 is equal to FR square, or FR is equal to root of F1 F2. So this is how you find the relation between. Sometimes in your semester examinations you will be asked derive fr is equal to root f1 f2, or you'll also f naught is equal to root over f1 f2. So this is sometimes being asked in your examinations. for your semesters, derive the relation between half power frequencies and resonant frequency. So we will consider now the next part, what is bandwidth. We will write what is bandwidth and try to derive that. Uh, so bandwidth, we are about to do this bandwidth. So bandwidth is equal to f2 minus f1. It is f2 minus f1. It is a range of frequencies over which the current is 1 by root 2 times the maximum current, or the power is half of the maximum power. So we already have two expressions, yeah, let us consider two expressions that we have. We have omega 2l minus 1 by omega 2c is equal to r, and omega 1l minus 1 by omega 1c is equal to minus r. Now let's try to subtract these two equations. Let's try to subtract these two equations and get the frequency. Let's try to frequency bandwidth difference. So let me take first omega 2l minus 1 by omega 2c minus, you have to subtract, right? So let us take this as 1 and this as 2. So 1 minus 2 will give me this, minus omega 1l plus, minus into minus will be plus, 1 by omega 1c is equal to, this is 2r twice. This is 2 times of r, right? So this is equal to 2 times of r. Right now, if you can write this, omega 2l minus omega 1l minus 1 by omega 2c, omega 2c plus 1 by omega 1c is equal to 2r. Now let us take this to the next slide and simplify further. So let us consider this. So I want you to just try to simplify this. I'll just give you some few minutes, and we will, let me ask you what you are getting. So try to tell me what is that value that you got after simplification. So what you are doing, what is that you have got it after simplifying these two. Now take common L from this. Now let's take common L from the first part, that is omega 2 minus omega 1, that is what you'll get it. And let's take 1 by c common from the second part, so you'll get 1 by omega 1 minus 1 by omega 2 is equal to 2r, right? Now L into omega 2 minus omega 1 plus 1 by c into, let us consider the LCM, omega 2 minus omega 1 by omega 1 into omega 2 is equal to 2 times of r. But we know that omega 1 into omega 2, if you can see here in this derivation, omega 1 into omega 2 is equal to 1 by LC. Omega 1 into omega 2 can also be written as, see, if you look at this, this is omega 1 into omega 2 is equal to 2 pi f1 into 2 pi f2 is equal to, what is omega 1 into omega 2? So I'll just tell you that omega 1 into omega 2 is equal to 1 by LC. or you can also write it as omega naught or omega r square. So we will write L into omega 2 minus omega 1 plus 1 by c into omega 2 minus omega 2 minus omega 1 by omega r square is equal to 2 times of r. Right? Now if you can take common omega 2 minus omega 2 minus omega 1 plus divide the total sides by divide this equation by omega 2 minus omega 1, divide this by L, so you'll get this omega 2 minus omega 1 by omega r square is equal to 2 times of r. Now if you further write that, you'll get omega 2 minus omega 1 plus 1 by LC into omega 2 minus omega 1 by omega r square is equal to 2r by L. This is 2r by L if you are dividing it. Right? This is 2r by L. Now what is this omega 2 minus omega 1 plus 1 by LC into omega 2 minus omega 1 by omega r square? What is omega r square? You can also write it as 1 by LC, that is 2r by L. So you can cancel these two. So this is 2 times of omega 2 minus omega 1, omega 2 minus omega 1. So this is 2 times of omega 2 minus omega 1 is equal to 2 times of r by L. You can cancel these two. What is omega 2 minus omega 1? Omega 2 minus omega 1 is equal to r by L. Omega 2 minus omega 1 is equal to r by L. What is this? 2 pi f2 minus 2 pi f1 is equal to r by L. You can write f2 minus f1 is equal to r by 2 pi L. f2 minus f1 is equal to, this is called as the bandwidth, r by 2 pi L. This is the bandwidth of the series resonant circuit. Now let us try to find what is, so this is bandwidth of series RLC circuit. Bandwidth is equal to f2 minus f1 is equal to r by 2 pi L. So let me now discuss half power frequencies expression. Half power frequencies expression, that is, what is the expression for f1, what is the expression for f2. Now we already know that f2 minus f1 is equal to f2 minus f1 is equal to r by 2 pi L. f2 minus f1 is equal to r by 2 pi L. Now if you observe this graph, now let us consider this graph of impedance or current, sorry, this is current versus frequency, this is current versus frequency. So this is half power frequencies. So this is f2, this is f1, this is f0. Now if you observe this distance is total distance. Now this is half of that, that is, this is half and this is half. What can you write from this? Can we write it as f2 minus f naught is equal to half of f2 minus f1. So that is half of, what is f2 minus f1? R by 4 pi L. So this is f2 minus f naught. What is f2 is equal to? f2 is equal to f naught plus 1 by 2 times of r by 2 pi L. So this is higher cutoff frequency is f naught is equal to, sorry, f2 is equal to f naught plus r by 4 pi L. Similarly, if you take the same graph again and let us see if this is the current curve, omega versus current. What is this? This is FR. These are half power frequencies F1 and F2. Can I write FR minus F1 is equal to 1 by 2 times of F2 minus F1? So what is F1 from this? It is FR minus 1 by 2 times of f2 minus f1. What is f2 minus f1? Bandwidth. So fr minus 1 by 2 times of r by 2 pi L. So this is r by 2 pi L. So can I write f1 is equal to fr minus r by 4 pi L. So these are the half power frequencies expressions for half power. Ajay Kumar CH, good evening. These are the expressions for half power frequencies f1 and f2. So today, so we have got what are the expressions for f1 and f2 as well, cutoff frequencies, lower cutoff frequency and higher cutoff frequency. So in this session we have covered what is resonance, what is series resonance, and also we have discussed what is resonant frequency, and also we have found its expression 1 by 2 pi root LC for a series resonant circuit, and where impedance, we have also found the impedance, we have considered series RLC circuit, we have found what are half power frequencies, also we have derived the relation between half power frequencies and resonant frequencies, and we have found expressions for f1 and f2 as well. This is f naught minus r by 4 pi L. This is f naught or fr, as I have taken fr plus r by 4 pi L, which you can see. Bandwidth r by 2 pi L, we have also found what is bandwidth. Bandwidth is f2 minus f1 is equal to r by 2 pi L. So these are some of the things that we have discussed for today. So we have discussed resonance, to be specific, series resonance today. Its FR value, bandwidth value, F2 minus F1, F1 value, F2 value, as well as the relation between F0, F1 and F2. So let me also once again tell you about this combat. Unacademy has come up with the Unacademy Combat, India's largest fortnight competition for GATE. It's a combat with best questions by the best Unacademy educators, and it is the challenging questions curated by the best Unacademy educators. Questions guaranteed to keep the test engaging, challenging, as well as fun. You can see a sort of question here. And it also has the super fast and fun with real time ranking. See how you rank against others with a live leaderboard after every question. So the compete with you need to compete with the best and know where you stand among all other contestants. The performance you'll get live. And also we will have you'll have get in depth video solutions for the questions right after the contest, and get detailed video solutions by the top educators as well. So you can compete, crack and conquer. You'll have the score, get scores of your speed and accuracy, steer clear of negative scores, leaderboard, get to know you have the rating, and take combats, get it right and improve all your rating, and climb through the ranks and earn a big badge of honor. So compete with the best and win these following amazing prizes of Apple MacBook Air, Apple iPad Mini, Apple AirPods, and rupees 1000 Amazon vouchers for top 100 rankers, and these are for the top 1, 2, 3 rankers. So to conclude, Unacademy Combat, it has the largest fortnight competition for GATE, challenging GATE questions created by our best educators, super fast and fun with real-time ranking, compete with the best and detailed video solutions by the top educators. Please do enroll for fee on December 16th, 6 p.m. It begins, and you can register now and win exciting prizes as I told you already. So this was all about today. We have discussed the resonance, the takeaways for today's session that I have already told you. The takeaways of today's session: resonance, series resonant, resonant frequency, F1 and F2 expressions, relation between resonant frequency and half power frequencies, and bandwidth as well. Also, we have discussed how does the impedance and vary with frequency, and how do they change. I've just taken some approximation examples to let you know how does impedance varies with frequency, as well as how current varies with frequency in a series resonant circuit. So we will continue this session of resonance in the next class as well, and stay connected. You can join my session. Nice explanation, sir. Thank you, Karthik. So we have India's number one study channels: Creatrix Gate, Unacademy Gate, Unacademy Gate CE, Unacademy Gate Telugu, Unacademy SSC JE, Unacademy Computer Science, Unacademy Gate Questions, Unacademy Electrical Junction, Unacademy Engineering Foundation, Unacademy Pathshala, and Unacademy Semester Exams. Please do like, share, and subscribe, and use my referral code as YSK10 to get the maximum discount, and click on this bell icon to get notification of my classes. So I thank you all for joining me this session, and please stay connected. And